Hello, everyone. Welcome back to the channel. The kids have been talking about gearing up for camping this summer, and I figured I'd take a look at one of the camping devices we've used quite a bit in our house. This little LED light, little clip hanger here, charge port over on this side. And then there's an output, so you can kind of use this to also keep like a phone charged or something along those lines. And told myself, well, if we're going to go camping, then I'm going to probably need to repair this because, my 4-year old decided when we were using it for Halloween to light up our pumpkin because it goes from a white to yellow to kind of a red flashing light, that she would throw it in a bathtub, as one does. So, can we take this apart and can we get it repaired? Let's see how it goes. I'm gonna zoom in and look at all this carnage. I'm not sure this one's salvageable. Uh, Lipo batteries themselves are awfully swollen. You could tell because there is a bow across this board, and every major component on this thing is extremely corroded, rusted, etc. Highly doubt it even powers up. I'll tell you what I'll do. I'll clean everything with some isopropyl alcohol. I'll get this battery out and I'll try to power it up with a power supply. It is cleaned up. You can look in that upper right camera. You can see how instead of this being flat, how convex it is. I guess swollen battery. Yeah, definitely not safe to power up. Now, just because there's a lot of rust, corrosion, etc. on parts does not necessarily mean that these parts are bad. We'll just poke around the board for a few seconds. So what I'm going to do is I'm going to check the on-off button for continuity. What else can we do? We can see if any caps are bad. And, if there's an IC, we'll learn that at power up. So first things, let me zoom out of here. I'll move that over that way. Good. We got that in shot now. Okay, so there's probably a lot of corrosion inside the switch itself. That does not seem to be working at all. Let me check some other things. We'll put red probe on ground. Right, so right probe is on the battery. We got that there. think these caps are going to be okay. Let's check our resistors. I'm not really looking at the value. I'm just seeing if we've got a measurement. 10 ohms across that one. And that is a 10 ohm resistor. Am I getting anything across this one? For a second. Nothing across that one. Yeah, got something across that one. And we got value across there. Value across there. Almost got a bunch of zeros, so that's right. Yeah, might just freshen up the solder across those pads. Let me check across this inductor with the exploded on the cap this off. That inductor, I got 0.6 ohms of resistance. We'll call that good. So as of right now, the only issue I'm really seeing is maybe touching up some solder on a small little resistor here. I definitely have an issue with this on-off switch. Let me see. Can I work some QD cleaner or anything down there? Get it worked out. We'll see how that does. Work that quite a bit. Maybe try to get a little bit of isopropyl alcohol down in there too. I highly doubt this will resolve it though. As rusted as everything else was, this is probably not going to resolve that on and off switch. Okay, let's try it one more time. I am 0 ohms across that way. And let's see what happens when I press the button. Hey. So maybe I needed to go diagonally. No, we're back to the button no longer working. Or sometimes working. Hey, let me see if we can just try and power this up. And get this up to about 5 volts. There we go. Yeah. So it is safe to say that all we really need is a new on-off switch and battery. One light. 2, 3. Blinking. And done. So yeah, I'm going to have to get a little 5 volt, how many? 1800 milliamp hour LiPo battery. Input 5 volts, 1 amp. This micro USB input's going to have to get swapped out as well. There we go. And right there on the edge. I'll bring it off to the side. Here you go. Yeah, that's corroded. There's no salvaging that. We'll get that swapped out too. All right. This is a fairly straightforward repair. I've got all the parts in front of me in order to get this accomplished. Ordered some tactile buttons off of Amazon, assorted type. One of these will definitely fit this tactile buttons in here. I have an assortment of micro USB connectors to replace the one over on this side. And we got ourselves a 3.7 volt lithium powered battery at 1800 milliamp hours. I probably could have gone with a slightly bigger amp hour, but I was concerned about size and it fitting in, and it definitely makes sense that you would use I might have said that battery was 5 volts. So I was speaking. It makes sense that you'd use a 3.7 volt battery, and there's most likely a some kind of boosting mechanism in here that takes it up to approximately 5 volts for the output of here. And we can confirm that when we test it, which we will do with a little USB tester. So what I need to do is get this button replaced, or we'll get this micro USB replaced and get the battery in it and get it charged up and put together and see how it functions. should have been. Okay, well, we are back together, and you might have noticed some of this during reassembly, but we do have battery charge, so plug it in. There we go. And you can see we've got a really pale green light on the bottom. Should be shining through here, but the board is kind of warped. We're drawing 0.81 amps, almost an amp charge. At let's see, 5.04 volts. So that's where we're at there. That will charge the battery that we have in. Let's see, we got all the lights working. Red, flashing red, single white light, and then the entire outside light. So let's tell you what, should be charging. We can move that over to there. Let me put this at the output, and we should see 5 volts at the output. If I can get my little tester down in here far enough. There we go. Oh, I just broke the connector. There we go. Oh well. I mean, who's really gonna be spending more money to repair one of these things than what it probably costs to just buy it new? That's just my assumption. Okay, 4.85 volts at the output, and yeah, I can use my phone to kind of test that. And yeah, we are charging, although it is, yeah, incredibly slow amperage, but yeah, we've got a charge. We are charging from there. 4.6 at 0.22 amps or 220 milliamps. Okay, so I was right. 3.7. Looks like we have a some kind of small boost converter, step up transformer, something in there, taking 3.7 to about 5 volts. But that is 100% in there, and I guess I'll just stick that in there as best I can. Well, there you have it, folks. We have successfully fixed this little camping light right here, and in perfect time to get ready for camping here within about a month. So if you enjoyed this little repair video going along with me, let me know in the comment section. If you are new to this channel, please stick around. There's a lot more videos than this one for you to watch and enjoy. There's quite a bit of content for you to choose from. I mean, you're already here. Why not subscribe? All that being said, thank you all for watching. Take care and goodbye.